Yeah, good morning, everybody. I hope you've had a great time at EuroSciPy and aren't yet too tired from all the nice interactions and socials. Time to kick off the session here. We're going to have a pretty versatile and mixed program. And yeah, Nikita Churikov is going to kick us off now with his tools on small molecule design and visualizations in the web browser. Join me in welcoming Nikita with a warm applause. And make sure that your devices are switched off, silent, and you're being recorded. Yeah?
So, hello everyone. Thank you for coming. And today I would like to talk about building drug discovery web applications with PyScript, Ketcher, and rdkit. So I hope you all are doing fine and are not too hangover from yesterday, or maybe you are. But still, yeah. If you would have opened the link, you would have found the link to these slides, and you can later on do that, and you can actually try all the things that will be in this presentation yourself with no problem. But two words about myself. My name is Nikita again. I go on the internet under Churnikov tag, and I work as software engineer at SciLife Lab in Sweden, and my background is in applied mathematics and data-related software. So imagine that you would want to build something like this. You have some kind of molecule input in some form, and you would want to do something with these molecules as input, like predict some properties, or maybe run retrosynthesis, or predict some other computational tool, to use some other computational tool. How can you input molecules? Well, there are ways. One is this smiles notation. You can just make this input field and write some in this form molecules, but I mean, who does that? You would probably want to draw them, right? And there is software out there that can do that directly in the browser. I will mention these ones. I know about them, but maybe there are others. So Marvin.js is nice, but it's a bit complicated in my opinion with licensing. There is this JSME. It's free, but not really pretty. ChemWriter is sort of free, but it's again a bit complicated with licensing. Then there is Ketcher, which seems to have no catch because it's free, open source, and with really permissive license, so you can actually do whatever you want with it. It's worth pointing out that there is this thing called Streamlit Ketcher that you can use. It's a wrapper around Ketcher using Streamlit, and you can build like pretty good Streamlit application with it, with Ketcher as an input, but I could not make it work with STLite, which is Streamlit that runs on top of Pyodite. So maybe if you would want to try it yourself, you can go to this gist and try to do something with that, but I could not make it work. So here is the talk. And also, if you would like to check out all this drawing software, you can, but I won't do that right now. Do it yourself later if you want. So Ketcher, how do you add it to your application? You need to download it first, and then when you unpack Ketcher, you get this folder structure. And specifically, we need we need the whole folder, but we need this index.html file, which we can embed into our web page. And here, this presentation is running in the browser, so I can try all things out directly here. I can draw nonsense because I'm no chemist, so I'm allowed to do that. Yeah, so this is the folder structure that you would get after you add Ketcher to your web application. Yeah, it's already a web application actually. And you have to have your main index file here, and in children directly, you will have Ketcher and this index.html file. And this should already work. And with that, we can build already something. We can add inputs. We can add these buttons that would do something. And for instance, here, I can set molecule. I can set reactions. I can get data from Ketcher. Already fantastic, in my opinion. And all this is done actually with PyScript and using JavaScript API, yes, but through Python. See, here you see that we have input with this identifier, and in this button we have this PyClick attribute that calls this setMol function, and inside of it we have identifier of a Ketcher window and call of this function here. Wonderful, in my opinion. Like I don't need to learn any JavaScript to do that. I know Python, so in my opinion, it's nice. And I can even get this button here and put it on the next slide and interact with this window on the next one. So here, for instance, you can see that I already changed this molecule here, but this output did not change. Now, if I would press this button, this would change. Well, why not do that? A couple of words about PyScript, if you don't know. So PyScript, you can treat it as a Python that essentially runs in your browser. It's built on top of a thing called Pyodide. So PyScript, actually, it provides a set of, an array of standard things that you can use to build front ends and interact with elements on it using Python. And Pyodide, you can use it if you need to create something custom. So what are we waiting for? Like, just pip install rdkit, right? Everything have been working out this far, right? Well, not quite. It's not complicated to add packages. In addition to these scripts which add PyScript to your web page, you also need to add this config, which has packages defined that you want to install. Well, sure, why not do that? And here I have an example from Matplotlib that draws plots, and this is REPL, so I can directly in the presentation change it to, for instance, cosine, and this would work. Well, sure, we don't have much time, so let's add the kit, right? It's on PyPy for a couple of years now. Why not? Well, it won't work for now because because the thing is there are like two types of packages that PyScript or Pyodide can work with. Either packages that are on PyPy with this suffix in the end, which means that it can work on any operating system and on any CPU. Unfortunately, rdkit is not. So it has to be built there also for Pyodide, along with other like operating systems and processors that are out there. But it could be done, and the efforts are being done on that front. So just it will take a bit of time. You know, we got to PyPy rdkit, so we will get probably this as well. But for now, maybe this presentation is over. Well, not, because we can use actually rdkit.js for now. And this is how you add it to your page. You need to do that, like add this JavaScript script, tautology. And this is how you initialize the rdkit module in your web page. And then now you can use this rdkit module through JS module, which I will show in a second. Setup. So setup was that. And now, for example, I will set this molecule here. And this is how you get molecules from this window within REPL. Unfortunately, REPL runs, it cannot run asynchronous code, so we have to wrap it into this async IO create task, which is a bit ugly, but you have to do that. And now we get this mol object, rdkit's mol object, by importing this JavaScript that has access to the whole array of functions that JavaScript has. And for instance, from examples of rdkit, I can do that. I can draw molecules using rdkit by this get_svg. And also, as an example, I can get descriptors. And this would be the output for caffeine molecule. Well, we are done. Like we've created sort of a drug discovery web application entirely within browser using all these tools. Now imagine all the stuff that you can do with it. Like you don't need any hosting now. You can create for, like, if you would like to create something for just visualization with molecules, you can use GitHub pages and serve your static files there. And it would work. You can show off your next drug discovery something there. Or you can do that for your internal company. But a couple of drawbacks. It is a bit slow, like PyScript takes a bit of time to load. Like if I would reload this page, you can see that it takes a couple of seconds. Like it's not a catastrophe considering that internet is fine here, but still it takes a couple of seconds to load, which is not ideal for internet. Also, API increasingly rapidly changes. Like half a year ago, it was a lot different than now. So yeah, it is what it is. And also, it's not yet friends with all the stuff out there. For instance, I could not use other presentation tool just because it used Vue as a front-end framework. So I could not use it with PyScript because it forbids script tags. But still, maybe PyScript is not ready for production yet. But maybe it can help you make friends with the browser. So if you have ever been afraid of trying doing something in front-end, give PyScript a go. Thank you.
Okay, we have time and room for a few questions. Okay, maybe I can start with one while no one is deliberating yet. Yeah, really fascinating. Thank you for the presentation. I would be curious where you see the future of applications with this tool. So one thing I understand based on what you have shown us is that this is really nice for displaying molecules, and there's clearly an educational purpose or a communication purpose. Is there also something where you could use browser technologies for more quantitative aspects, or yeah, is there also something that that you could add to add dynamic elements and show like a change in molecules?
I think so. Like for instance, with rdkit, you can draw, like you can highlight molecules. You can like tear them apart with it. Like it could be done. But there are also JavaScript libraries out there that can work with molecules. And there are Python libraries that could actually be built for Pyodite with no problems at all. For instance, this Python, I think, SciPython, it's like Python for chemistry, which is an alternative to PyScript or to rdkit. So there should not be any problem with like porting it. It just needs to be built for Pyodite.
So you have to how to secure your API. There is such question on the slide. So can you tell us how to secure your API if we are using PyScript? Is it possible?
Well, I got to like using the PyFetch method from PyScript, right? And I was thinking that it seems to be fishy, you know, like you can actually see API calls, and so you can like directly use APIs. So short answer, yes, and you can, but I mean, I unfortunately won't like be able to describe everything. That's why I provided this link. So if you are interested, you can read about it. But there are an array of tools that you can use. That, yeah.
Okay, thank you.
On one slide, you showed how to specify dependencies, like matplotlib in your case.
Yes.
How does it work technically? So when the user loads the page, they always have to pull the wheel?
What was the last thing?
Like when the user loads the page, they always have to pull the matplotlib wheel from PyPy in the background? Or?
Well, the thing is, it's because it is dependent on some C libraries, and I think it's C++, right? So the thing is, it's built directly for Pyodide. So it's not being pulled from PyP directly. It's being pulled from another CDN that is provided by Pyodide organization. And so, yeah, it's pulled from there. But still, it's being pulled and like sort of installed into your web page.
Okay, thanks.
You didn't have.
I think we still would have room. I would be curious, could you share with us some of the current use cases for your library or for this tool? Some customer success stories, so to say? Or?
Well, I can share sort of like, yeah, like you see, I dropped in the stock thoughts about Marvin Dash, you see here. But this was actually a solution before all this PyScript and Ketcher and Streamlit tools. If you would try it, you would instantly see that it is really inconvenient. Like, not really, but it is a bit inconvenient to use. So it is a library that allows you to use Marvin.js and the Dash application altogether. And the problem was that it was not really convenient to use. But now you can see that it seems not hard. It seems convenient to me, at least. And I feel like, and we used Marvin.js for our demos for wet chemist, so to speak. And we could have used now Streamlit Ketcher or PyScript for our needs back like 4 years ago, I think.
Yeah, that makes a lot of sense. Yeah, thank you. Thank you once more, Nikita.
Thank you. Thank you, everyone.